I started the recording for today's class. দেখো কেউ কোথাও আটকাছো কিনা? আচ্ছা, আমি কিছু এক্সপেরিমেন্টাল কিছু পয়েন্ট নিয়ে আলাপ করি। One of the things that you have already learned in the first acceleration motion, the kinematics dynamics chapter in graph related classes, that whenever you are trying to work with a graph that has a significant portion to be straight line and then another part starts to out to be curved, the best way to determine the point where the straight line finishes is to hold up a ruler against it. So if you hold up a ruler against this line, you'll see that from a certain point there the distance start to increase significantly. That is basically the point where your straight line essentially finishes. So this can actually help you to find out this answer pretty easily. State the mass that stretches the spring to the limit of proportionality. So এখানে এটা এই লাইনের এগেইনস্ট রুলার ধরে দেখো যে এখানে কতটুকু পর্যন্ত আমাদের লাইনটা স্ট্রেট লাইন আছে।
0.5
or 0.6?
6.5 or 0.6 এর মধ্যে এখানে কেমন একটা বাঁকার মতো লাগতেছে আমার।
That's why you should hold the ruler against it. Don't assume. Place a ruler against it so that you can definitely know exactly what is the point of bending away. Hold a ruler against the straight line part. You'll be able to find out the end point. I think this will be 0.6 kg. Take the weight of this mass, so this is pretty simple.
So maybe আমার ওখানে প্রিন্টিং মিস্টেক, বাট আমার 0.6 এর ওখানে একদম ছোট একটা বাম্পের মতো
এখানে।
Yes sir, maybe আমার প্রিন্টিং এ কোনো কালিতে ঝামেলা হয়েছে।
আচ্ছা, that is actually possible because
0.6
sometimes it does happen, but if I zoom in on this one, you should be able to see this much more too clearly. এখানে একটু বাম্প আছে তাই না?
জি স্যার, আমারও একই।
It also appears that এখানে একটা বাম্প আছে, but I believe that it is to be 0.6. What does the mark scheme say? No. 0.6 to 0.67. So somewhere in between, not 0.5. আচ্ছা, এরপর দেখি Explain how the graphene drawn in figure 1.2 is defined when the experiment is performed at a place where the gravitational field is weaker. Essentially, if the gravitational field is weaker, then we're going to have two different difference in this graph. First of all, the gradient, if the gravitational field is weaker, it means that the same amount of mass will be producing a smaller force onto the spring. So if you have smaller force, your extension will be small as well, because by Hooke's law, force is proportional to deformation or extension. So for the same amount of mass, you'll be getting a much smaller amount, significantly smaller amount of extension. So the straight line part of this graph would be more slanted, or you can highlight that the gradient of the straight line part would be less, or it would be more slanted. The slope would be less. You can write in any wording. That's one thing. And the proportionality, limit of proportionality, or the bending part or the end point of the straight line would happen at a much bigger amount of mass. So 2 points we're going to talk about. First of all, the straight line should be more slanted, or it would have less slope. And because bigger mass now produces small force, so the limit of proportionality would be achieved at a much higher mass value. These are the 2 points that I can think about. Let's have a look at the Marxian. Graph lower or smaller extension for the same mass, or more mass needed for the same extension or weight or pull of gravity of the force on spring, less for the same mass. এটা কি state and explain ছিল? হ্যাঁ, state and explain ছিল. So they didn't necessarily go for the higher value of the limit of proportionality. They explained that the graph would be lower, or the gradient should be less, and then they gave a reason why that should happen. I actually didn't see the explain part. I only thought that it's a state question for 2 marks. That's why I went for 2 points. My bad. I should have read the question much with better attention. So this is these two lines that you can see over here. These two lines are alternate to each other. These are the observation that we should expect. And the last line, this third line, is exclusive. This is the reason that why should that happen. So pretty simple stuffs. You should be able to write them up in proper wording. Not much difficulty. আচ্ছা, এখানে একটা জিনিস বলি, in many cases whenever we perform quite a lot of different experiments. For example, for this one we are performing the experiment with the spring and the mass and the ruler. It is important that we place a pointer that looks like this, which should touch the ruler. This is important to avoid parallax error. The idea of parallax error is that if we don't have the marker touching the ruler surface, then there is always a possibility that we might have different reading by looking at the apparatus setup from different angle. So this is a problem that can happen. To avoid that problem, we usually use a very soft yet not so flexible pointer. For example, this pointer could be made from a piece of paper and could be taped onto the at the bottom part of the spring. So it's just a simple piece of paper which should be able to touch the meter rule surface over here. The reason it needs to be soft because we want this spring to be under the effect of force that is obtained from the weight exclusively. We would not want this contact between this pointer and the rule to actually introduce any significant friction in the system, because this is our measured mass. So F equals to kx in this equation, we're going to use the force that would come from the weight of this mass, which in this case is 4 Newton. So we would not want this to be a very rigid object. For example, if this was an object made from plastic or maybe from styrofoam, then it is very much possible that as the spring starts to extend out because, under the effect of the weight, this point of contact might actually provide some significant friction. So that way we might not have the actual value that we are trying to look for. So this is supposed to be a small, quite flexible, yet workable thing, typically made out of paper, which can be taped onto the spring so that we can avoid parallax. So that's the purpose of the pointer. Sometimes this pointer is also called a fiducial marker. I'm going to write that spelling. Sometimes this pointer can also be called a fiducial marker. This is just a fancy name for stuffs that help us avoid parallax error. All right. এখানে কোনো ঝামেলা আছে কিনা দেখো। If there is any difficulty in this question, you can go ahead and keep on solving this question paper as we go on for the discussion. If you get stuck anywhere, I can help you. Okay. দেখো, if you have any problem, you ask me. Question number 3.
Sir, I have a problem.
কত number?
Sir, number 3, last B2.
আচ্ছা, দেখতেছি. Figure 3.1 shows a man using a chest expander to increase the strength of his arms. The chest expander may be considered to be a single spring. Okay. Figure 3.2 shows the force needed to produce different extensions of the spring. So different force values, different extension values, Newton and centimeter. Okay. The man increases the force of the spring from 0 to 180 Newton. The spring extends by 30 centimeter, and average force exerted during this process is 90 Newton. Okay. Calculate the work done on the spring. To do the work done, you have to do force into distance. Important thing is to convert this centimeter into meter, because you would want the work to come in joule unit. So that's important. Number 2 says 20 extensions are
Sir,
made.
can you give namaz prayer?
Yes. Just a second, আমি এই কোশ্চেনে টালাপ করে নেই, we'll give a small break. 20 extensions are made in 1 minute. Calculate the power used to extend the spring. So in 1 minute, that is 60 seconds, and there are 20 extensions made. So a total amount of work would be this much multiplied by 20 and then divided by the 60 seconds. That works. B number says the force at the limit of proportionality of the spring is 800 Newton. Calculate the extension of the spring when the force is 800 Newton. Okay, this we can calculate directly from these proportions, any of these proportion, F equals to kx. So, okay. তোমার প্রবলেম ছিল এটাতে, তাই না?
Yes, sir.
The force on the spring is increased from 800 Newton to 860 Newton. Suggest what happens to the extension. Okay. The question says over here that the limit of proportionality of the spring is 800 Newton. Now we have expanded the spring beyond its limit of proportionality. So what this is going to do essentially, this is going to bring out some permanent deformation or plastic deformation onto the spring. So it says that suggest what happens to the extension. The force on the spring is increased from 800 Newton to 860 Newton. Such what happens to the extension. Okay, usually what happens, so there, other than looking at the mark scheme, I can try to answer this question on my own. There are, I'm going to write two different things over here, although there is only one mark because I'm not sure exactly what they are looking for. The first thing that I'm going to write is that if we draw the force extension graph of a spring, what we do know that we have a straight line part, which is the elastic behavior. And then the limit, beyond the point of limit of proportionality, the graph starts to lose gradient, which means up to this point, we have a pretty uniform increase of extension with respect to force. But whenever it goes beyond the limit of proportionality, then the same amount of force does not give you the same proportion of extension, which means the spring becomes easier to expand. That's one thing. So whenever we would increase the spring from 800 Newton to 860 Newton, do we have here? You can see that the extension of the spring, exclusively extension of the spring for an exclusive 60 Newton force, the extension was 10 centimeter. Because this region is in the plastic region or the permanent deformation region beyond the limit of proportionality, here we should have a bit more extension than 10 centimeter. So applying the same amount of 60 Newton of force should be giving us a bigger extension compared to 10 centimeter, because now the spring should become easier to extend. So one thing I'm going to write that the spring will extend more than 10 centimeter because now it is extending within in the plastic region. That's one thing that I'm definitely going to write. Although the question doesn't ask for it, that what happens to the extension. I mean, the question only says that the force on the spring is increased from 800 to 860. It doesn't mention essentially that after pulling it out to 860 Newton, we eventually let go of that force and eventually the spring tries to come back to its original shape. But this is not mentioned in the question, but I'm going to write a little bit about that as well. So
Sir, how do we know that it's in the plastic region?
Because the question says on this part over here, the force at the limit of proportion of the spring is 800 Newton. It mentioned that. So up to 800 Newton is the limit of proportionality. বুঝছো?
Yes, sir.
আচ্ছা. So additional to this, I might also try to write that when the spring is allowed to contract back to its original shape, some deformation would become permanent, or I can write that the spring would become longer than its original length. These are the 2 points that I can think about, but there is not enough space over here to write all of these sentences. There are only 1 mark and 2 lines. So let's have a look at the mark scheme, what they are expecting out of us. Number 3, B2. Extension more than 143 centimeter or extra extension is greater than 10 centimeter. I talked about this point. Or some extension become permanent. Okay, I also talked about this point. So any of these 3 expression works out. Yeah, works for me. Did you understand this part, which I just discussed, that why the extra extension should be more than 10 centimeter? এটা কি বুঝছো সবাই? সপ্তর্ষি?
Yes, sir.
আচ্ছা, এটা
Sir,
বুঝছো?
একটা question.
143 কোথা থেকে আসছে এটা বুঝছো? Any idea?
Sir, could you explain the 10 centimeter part again?
আচ্ছা, I'll help. আচ্ছা, আমি 10 centimeter part idea হচ্ছে যে within the part of the limit of proportionality, the force and the extension are directly proportional. So every equal increment of force gives you equal increment of extension. So up to 600 Newton, so 800 Newton, you would have the same proportion. I obtained information of 10 centimeter from this table, that if we apply an exclusive 60 Newton force onto the spring within the limit of proportionality, the extension should be exactly 10 centimeter. So for every 60 Newton of additional force, you would have 10 centimeter of additional extension. That's the behavior within the limit of proportionality. But now, because we extend the spring up to 860 Newton, which is beyond the limit of proportionality, the spring has become easier to expand. That's why the additional extension should be more than 10 centimeters. So I just picked up this value from here. That's one way to go for it. The other way we can go for it is that if you calculate the exact deformation amount that it is supposed to have for 860 from the same values that we have over here. For example, you can use any of these values. Let me show you a bit of a sample calculation. If I just choose any of these values, let's say 60 is to 10. This is my fnx value. So where is it? This one. So I can write that within limit of proportionality, the formula goes like that: f equals to kx, or f by x is a constant. So I can have different equation like that for f1 by x1 should be equals to f2 by x2. If I go ahead and write this equation, for example, one set of value from the table, 60 Newton by 10 centimeter should be equals to 860 divided by what is x2. If you use this equation to attempt to calculate out what should be the extension, this x2 should give you 143. Give it a try and see if it makes sense. এটা কত হয় দেখো তো ক্যালকুলেট করে someone
143.
exactly.
জি স্যার।
So this becomes 143. So তার মানে হচ্ছে যদি ইলাস্টিক বিহেভিয়ার হইতো তাহলে আমাদের এক্সাক্ট এক্সটেনশন টোটাল এক্সটেনশন হইতো 143 centimeter, but because this amount of force was within the plastic region, that's why it should be more than 100. Total extension should be more than 143. That's the first point that they mentioned. Extension more than 143 or extra extension more than 10 centimeter. Here the extra is given in bracket because this was an expected word but not mandatory. So if you only write that extension would be more than 10 centimeter, you'd still score full marks. But if you do write extra extension would be more than 10 centimeter, the examiners would be more pleased at you. And then the basic idea of the plastic region. That's basically it. বুঝা গেছে?
Yes, sir.
আচ্ছা. So we'll take a bit of a break, 10 minutes for Maghrib prayer, and we'll resume class at 6.10. Okay, we are back. We have resumed the class. We'll go further down from this question. Question number 4. Any problem from there? Anyone? We did solve this one, did we not? No. This question looks like we solved it. I think this is the one question that we solved, right? Last class. Hello.
Yes, sir.
Yes. Okay. Tell me anything that you couldn't solve or that looked very difficult to achieve, or the mark scheme didn't make sense.
Sir, I have problem in number 5.
5. Which one?
Sir, the last one, 5-2.
Achha. If opponent shows how the length of the string varies as the force is applied to it increases, force versus length graph. So length, so which means the original length was 11 centimeter, and from there it goes extension. Unstretched length is 11 centimeter. Determine the length of the unstretched spring. Explain how the graph shows the limit of proportionality is not reached. The spring is attached to a mass of 0.20 kg and placed on a frictional surface as shown in figure 2.2. The apparatus is placed on the floor of a car. When the car accelerates uniformly in the direction shown, the spring extends. What is meant by uniform acceleration? Okay, that's simple. The extension of the spring is 9 centimeter. Using figure 5.1, determine the horizontal force on M. Okay, if the extension of the spring is 9 centimeter, which would mean the total length should be 20 centimeter. So the 20 centimeter line gives us a crossing over here, which goes up here. There is one division above the midpoint between 1 and 0.5. So we have to find out what is the force of this point. Can we calculate that? Its smallest division is 0.05 here. So 0.05, this is 0.75,
0.8, I think.
0.80,
0.8.
0.8 or 0.80, yeah. So that is the force that we're gonna have from this thing. There is no calculation needed for this thing. I don't know why this space, we give this space, maybe to confuse you, because some student might actually try to do F equals to MA. I believe that this space was actually given to you for confusing it, because this is one mark question. You're supposed to use the graph to take a read off from the graph. There is no calculation required. But for the acceleration, you would need this space, because you have the value of force, you have the value of the mass of the block. Is the mass of the block given anywhere? Yes, it is 0.20 kg. So you can use F equals to MA to calculate the acceleration. বুঝা গেছে?
জি স্যার।
আচ্ছা, তোমার কি গ্রাফে রিড অফ করতে সমস্যা হয়েছিল?
ইয়েস স্যার।
আচ্ছা, okay. So, acha. Anyone else? Any problem with number 5? If not, number 6 দেখো.
স্যার 2 তে একটু বুঝাবেন।
Number 6. We have anything?
B8 2.
B8 2. Okay, দেখবো. Fifth experiment shows 0.4 kg mass hanging from at rest from a spring. State what is meant by the mass of an object. On figure experiment 1, draw an arrow showing the direction and the line of action for which the two forces that act on the mass. Write the name of the force next to each arrow. আচ্ছা, একটা হচ্ছে ডাউনওয়ার্ড অ্যারো দিবা, সেটার নাম হচ্ছে ওয়েট। একটা আপওয়ার্ড দিবা অ্যারো দিবা, সেটার নাম দিতে পারবা হচ্ছে ফোর্স বাই দ্য স্প্রিং, টেনশন ফ্রম দ্য স্প্রিং, পুল ফ্রম দ্য স্প্রিং. You can do either of them. These two forces should be in the same along the same straight line and start from the very center of the object, not from random places, and they should be perfectly aligned. এরকম না যে একটা ফোর্স দিলে হচ্ছে এই বরাবর আর একটা ফোর্স দিলে হচ্ছে ওই বরাবর. They are parallel but they are not in the same line. ওরকম আঁকলে মার্কস কম দিবে, because these forces are balancing each other out, so they should be perfectly in the same alignment, equal and opposite to each other, so that they can balance each other. B2 তে বলছে the gravitational field strength is 10 Newton per kg. Calculate the size of each of the two forces acting on the mass. Well, both the forces will be exactly equal to each other, because the question says that the mass was hanging at rest. So the weight of this thing should be 0.4 into 10, which is 4 Newton. And the second force would also be 4 Newton. You just only have to calculate what is the value of the weight, and that would be exactly equal to the tension of the spring, because together they are producing an equilibrium, which is causing the mass to stay at rest. So that's that. Non বুঝছো এটা?
জি স্যার।
আচ্ছা, beautiful. Number 6 will say the mass is pulled downwards to an extent. What happens to the upward force? Okay, if the mass is pulled downwards, then the upward force increases by Hooke's law, because F equals to kx. So when the extension of the spring goes higher, the force also increases proportionally. How much marks? Two marks. And that pretty much does the job. We'll have a look at the mark scheme. Upward force or tension increases because springs stretched or longer. Comparatively few candidates made sensible comments about the upward force. Full marks were obtained simply for stating that the force increases because the spring is stretched. Many candidates have stated that the force increases because of Newton's third law as a consequence of the increased downward force that pulled the mass downwards. No. This has nothing to do with Newton's third law. This example, this scenario has nothing to do with Newton's third law. Yeah, this was a wrong expression. This is the correct sentence, that force increases because the spring is stretched. That is good enough. 7 এ কারো সমস্যা? Anyone? Graph
Sir, graphটাতে আমার একটু প্রবলেম।
Okay, look at it. A pupil hangs a load of 45 Newton from a length of copper where the wire extends by 2.5 millimeter and does not exceed limit of proportionality. The gravitational field strength is 10 Newton per kg. Calculate the mass of the 45 Newton load. This would be pretty simple. W equals to mg. You can calculate the mass would be, I think, 4.5 kg. Using the grid in figure 7.1 to plot the extension load graph for this wire for a load between 0 and 45 Newton. So we are trying to plot an extension load graph, which means extension come on the y-axis and load comes on the x-axis. Let's take out this portion and attempt to draw this graph. Okay, so the question says that we had load at 45 Newton, wire extends by 2.5 millimeter. Okay, so this would be our extension axis. So you can write along this side if you want. Can I write? Yeah, okay. Extension slash millimeter. On this side, you can write load slash Newton. The maximum load that we are trying to plot is 45 Newton. So we have to do some thinking that how can we place this? If we start from 0, 0, so 10, 20, 30, 40, 45 can be very well placed over here. And on the y-axis, we are trying to plot the extension for a 45 Newton load. We are trying to show an extension of 2.5 millimeter of extension for the wire. So if you go from here, let's say 0, 1, 2, 2.5. So it's a very simple scaling that we can accommodate pretty easily. So we're gonna go for the labeling of the scale first. I'm gonna do this with a different color just to make point. 0, 10, 20, 30, 40, 50. I'm labeling 50 over here, but I'm not going to do the graph up to 50. The reason I'm not plotting 45 because whenever you are trying to label the scale or the axis of a graph, you are supposed to give equidistant labeling. If I did do 0, 5, 10, 15, 20, 25, 30, 35, 40, 45, I could have given the 45 value over here. But to make sure that to apply the 45 value over here, I would have tried all the 5 increment values label at these points as well, which in my opinion is absolutely unnecessary. The scale can be much bigger than what you're trying to achieve. The scale is a mathematical representation of the value, which is not an experiment obtained data. So in this case, I label the scale up to 50 Newton, but I'll definitely plot my graph up to 45. I'm not gonna go beyond the 45 Newton value because the question asked me to plot the graph up to 45 Newton, 0 to 45 Newton. So that's one thing. And then on the millimeter scale, I'm gonna write over here 1.0, 2.0, and 3.0. So this is my 2.5 millimeter mark, and this is my 45 centimeter mark, 45 Newton mark. So this would be my point of extension where I want to finish my graph. I'm giving a dot circle over here because that's how I prefer to label the point. Actually, the circle should be a bit bigger, about half the size of the square, which is a effective way to label the point. And then you have to draw a perfect straight line starting from the origin all the way up to that point. Perfect origin theta finite. I think this one works. No. Oops. Acha, ঠিক আছে. So that's pretty much it. বুঝা গেছে?
Yes, sir.
আচ্ছা, ইম্পর্টেন্ট পার্টগুলো হচ্ছে যে আমাদের এক্সিস লেবেলিং গুলো যাতে ভুল না হয়। এক্সিস লেবেলিং করার সময় আমাদের এক্সিস কোয়ান্টিটির নাম ইউনিট দুটোই লেখা লাগবে, ভেরি ইম্পর্টেন্ট। অ্যান্ড আরেকটা জিনিস হচ্ছে অলওয়েজ ফর এনি গ্রাফ the first mentioned variable comes on the y-axis, the second mentioned variable always comes on the x-axis. This is always true, always. Force extension graph means force first, extension second. Speed time graph means speed first, time second, which means speed goes on the y-axis, time goes on the x-axis. So distance versus time graph, if we go for the waves chapter, we're gonna see those as well. It means distance on the y-axis and time on the x-axis. So every single time, the first variable is the y-axis variable, the second variable is the x-axis variable. Okay, that's about the plotting. If we move on, use the graph to plot in figure 2.1 to determine the load needed to produce an extension of 1.3 millimeter. So let's find out where is 1.3. I'm going to use a different color, maybe this one. So this is 1 and this is 2.0, so which means every increment is 0.1. So 1.1, 1.2, 1.3, this is the 1.3 millimeter of extension. And the required force, if I find out an intercept, is somewhere over here. This force is not making a very perfect cross point with the corner of this box or this box. So This is 20 Newton, 21, 22, 23. The required force should be between 23 and 24. Somewhere over here maybe. So I could say 23.5 or 23.2. It should be definitely slightly bigger than 25, because you can see that the crossing actually did not happen exactly at the corner. If you try to think about this line of very negligible thickness, it did not essentially pass through this corner. It passed a little bit on the right side. So that's why I'm considering this amount of this slight bit of gap after the 23 Newton. However, I'll look at the Marxian to see what they have to say. This is question number 7, B. Question number 7B. Answer from candidate's line. Okay, so they allowed ECF from here, which means if someone messes up their graph, they're gonna mess this one up as well. But if this value written is correct according to the student's graph, they're gonna get marks for this as well. Many candidates use their own graph as instructed to obtain a correct answer, and most did so carefully and scored the mark. The question instructed candidates to use the graph, so candidates who calculate the answer were only credited when this answer coincided with the value that could be read from the candidate's graph. Acha. This is an important information. What this examiner's report says that the question exclusively mentioned that use the graph plotted in figure 2.1 to determine the load needed to produce an extension of 1.6 mm, which means according to the Marx scheme, you are needed to take this value out of your graph, not calculate. If you wonder, because the question already tells us that the spring did not go beyond the limit of proportionality, so essentially we could go for the mathematical calculation as well. Let's say f1x1 equals to f2x2. So if you place for f1x1 the known value, for example, for a 45 Newton force, we have an extension of 2.5 millimeter of extension. So you want to find out the force needed for 1.3 millimeter, and your unknown is the force. So you can also replace these values over here properly to calculate out the value of the force. This is also a logical way to achieve this problem, but this is not what the question asked us to do. The question asked us to take the reading from the graph. So people who actually attempted this and did find out an answer, they were only given the mark if this calculated answer was exactly matching with their graph. If this calculated answer, which is the correct answer, somehow did not match with their graph, which means let's say they did some wrong in plotting the graph or in the scaling or any whatsoever, then they were not given this mark at all. So the answer in this case, so they are exclusively watching, expecting the kids to use their own graph to get this value as per the question instructs. So it's important that you read the question carefully and follow the instructions as per. What you can do essentially is that you can do a bit of a rough calculation for over here to check that whether the value that you did get is correct or not. That you can always do, but this is not the direct way that the examiners are expecting you to do. But you can do this beside with a pencil, and eventually you can erase it to check whether your calculated graph value was correct or not. I would not recommend this. It's not essentially. As long as your graph is good, you should always end up with good number. বুঝা গেছে কি?
Yes, sir.
Yes, sir.
Okay, so this was that one. Now we have a huge blank space, so the paper 2 is practically over. This is beautiful. We can go back to our regular working that we need to discuss from here. So এখানে যেন কত নম্বর পর্যন্ত আলাপ করা হয়েছিল? গতকালকে বলছিল আমাকে, আমি ভুলে গেছি আবার।
Number 18 পর্যন্ত।
18 পর্যন্ত. So I'll go there and tell me all the questions that you have beyond number 18. Anything that you would like to discuss or anything that didn't make sense while you attempted to do the Marx scheme. 19, anyone problem? 20.
19C.
19C. Okay, the question is about the piece of paper falls from 4 meters above the ground. Figure 1.1 shows how the height h above the ground varies with time t. So the paper falls from rest because the initial gradient is 0, and then it speeds up because the gradient of the graph is increasing, which means speed is increasing. It reaches an uniform speed at around, I think, not this one, I think 2 divisions after 0.5, somewhere over here, which is the terminal velocity, then it falls to the ground. Beautiful. The question says, as the paper falls, energy changes from one form to another. State the main energy change between t equals to 1 second to 2 seconds. Okay, here are a couple of things that I need you to understand. From 1 second to 2 seconds, we have an uniform speed of the paper falling because the gradient of the h versus t graph is a constant, which means speed of the falling object or paper piece is constant, which means it has already reached terminal velocity. Because the speed of the paper is constant, no further kinetic energy is gained. The paper has some kinetic energy because it is falling down, but it is not increasing over time. So over this duration of time, it has a constant amount of kinetic energy, but it is still falling down. So it is definitely losing GP. So it is losing GP, but it is not gaining kinetic energy, which means all the GP lost is being used to overcome the air resistance, or you can let's say the frictional heat loss that converts to heat into the surrounding. So the only so that's the idea. এখানে আমাদেরকে শুধু স্টেট বলছে না, হ্যাঁ রিজনিং দিতে বলে। So the main energy change between 1 to 2 seconds. I'm going to write that GP converts into heat of the atmosphere due to air resistance. Although the question didn't ask for an explanation, but I'm going to give an explanation that due to air resistance, I'm going to write that.
Sir,
Yes.
I'm sorry, could you repeat why it doesn't change to kinetic energy?
Try to understand. This is h versus t. This is the first thing that I need you to see. This y-axis variable is height, which means the gradient of this graph should be speed. Initial speed is 0 because the graph starts being tangent with the horizontal line, and this one speeds up, and beyond a certain point, from about this point, the speed becomes constant because it is a straight line now. So for this entire duration, the speed is a constant. If you have a constant speed, it means your kinetic energy is also constant. The paper is falling down, but it is maintaining a constant velocity, which means you do not have any further gain of kinetic energy. For example, over here, the kinetic energy of the paper is, let's say, 2 joule. That 2 joule of kinetic energy remains for the entirety of the remaining duration. বুঝছো কি বলছে? কাইনেটিক এনার্জি
Yes, sir.
আছে, বাট কাইনেটিক এনার্জি বাড়তেছে না, বাট জিপি কিন্তু ঠিকই কমতেছে, কারণ অবজেক্টটা তো কন্টিনিউয়াসলি হাইট লুজ করতেছে। সো এই লস জিপিটা কোথায় যাবে? এটা ইউজ হবে হচ্ছে অ্যাটমসফিয়ারের পার্টিকেলস গুলোকে মুভ অ্যাবাউট করার জন্য, যেটাকে আমরা এয়ার রেজিস্ট্যান্স বলি, and that will be converted as heating or heat energy into the atmosphere. This heat energy will never be perceived by our skin because this is a very small amount of energy dispersed over a huge number of air particles, but energy has to go somewhere because energy cannot be created or destroyed, can be only converted from one form to another form. So that's the only logical answer. বুঝতে পারছি? আচ্ছা, so this was for 19. Uh, 20. Anyone?
Sir, can you also show 19B once?
This one.
Yes, sir.
Calculate the speed of the paper at time t equals to 1.5 second. All that you have to do is to calculate the gradient of this graph at t equals to 1.5 second. Kids, remember, this is the important bit that you should always remember while working with graphs, that the gradient quantity is the quantity that you get from dividing the y-axis quantity by the x-axis quantity. So displacement versus height versus time graph, which is distance over time. The gradient is speed. So you have to calculate the gradient of this graph at this point. That can be very easily done. Let me show you. If I take this out, delete this whole paste. So we are asked to calculate the speed of the thing at 1.5 second. So we are trying to find out the gradient of this point. So this is a pretty long straight line. So you can use any size triangle that matches with this straight line and go for to calculate the gradient. For example, I can try to draw a triangle that might as well be this much big. I hope this fits here properly. Wow, it does. So I could try to draw this much big of a triangle. If you don't want this much big triangle, you can draw a bit smaller. You can draw even bigger, but do not go into the curved part. Stay within the straight line part. So we can now simply calculate that what is y-axis spacing over here. How many meters are over here? It's 1, 2, 2.1, 2.2, 2.3, 2.4. So 2.4 is our delta y, and then that in terms of time we have exactly 1 second. So that is 2.4 meter per second. বুঝছো কি? এই পার্টটা কি বুঝা গেছে? না বুঝা গেলে বল, I'll help you again. I'll re-explain.
স্যার বুঝেছি।
আচ্ছা, ট্রায়াঙ্গেলটা কেন আছে সেটা বুঝছো?
ইয়েস স্যার।
আচ্ছা, সো গ্রেডিয়েন্ট ক্যালকুলেট করার জন্য আমাদের গ্রাফে কিছু একটা ট্রায়াঙ্গেল দেখাইতেই হবে। ট্রায়াঙ্গেলটা বড় ছোট হইতে পারে, ব্যাপার না, বাট what is really important that you should choose the corner of the triangles such that you have a good cross point, something like this one, that one that I have already chosen, or maybe something like this one, or something like this one. You should never prefer to choose points like this or points like this that cuts through the center or middle of two cross points, because obtaining their coordinate is pretty difficult. You have to assume values, so prefer to avoid this same type of points and choose good cross point. You would be always set to go. Okay, number 20. Anyone? এগুলো খুব simple question. If you do revise your class notes a bit, they should help you a lot. তোমাদেরকে যে ক্লাস নোট দিছি, সরি, তোমাদেরকে যে ক্লাস নোট দিছি তোমাদের নোটসের ভিতরে, ওটাতে প্যারাশুটিস্টের গ্রাফের ফুল ডেসক্রিপশন লেখা আছে না? এটাতে আছে কি?
Yes, sir.
কই আছে এটা? আচ্ছা, এই যে এখানে। Okay, this is the energy conversion thing, and then we have the whole description over here to this point. Yeah, beautiful. This is a good description that you can go through it. It's quite elaborate and pretty much accurate to all of his points. Acha, no problem for question number 20. 21. Anyone? 22. 22 is here. Let me take it in a booklet format, maybe. Would that be helpful? Yeah, this format helps a bit more. 22, 23. Question 24 এর যে গ্রাফটা ওরা দেখাইছে, এই গ্রাফটা নিয়ে আমার কিছু অ্যালার্জি আছে। অ্যালার্জি হচ্ছে যে what they are showing over here, that this fall of the decrease of the velocity is nearly vertical, as if the person is undergoing infinite deceleration for this part of the deceleration. This is highly unlikely. This is, in my opinion, this is a what can I say, software generated curve, and they didn't bother to put in enough variable to make this graph a bit more realistic. But in true case, this will never be such a vertical curve. This will be very steep, but not this kind of a vertical line. That's highly impossible and inappropriate for a properly drawn speed time graph for a parachutist. So এটা actually হয় না, realistic case এটা হয় না, but for mathematical case, for hypothetical or standardized case, we can essentially have these kind of things. তোমাদেরকে একটা বেসিক ম্যাথমেটিক্যাল প্রবলেম দিই, কাইনেমেটিক্স বেসড। তোমরা একটা কোশ্চেন লিখো, কোশ্চেন আমি বলতেছি, pull up your copy and write a question. Everyone, তোমাদের কপি হাতে কাছে আছে?
Yes, sir.
লিখো, this is a pretty slightly far-fetched question maybe for your level, but it's a very good mental exercise. There is no harm done if you cannot solve this question, but if you can think of a way to solve this question, this would be very nice. But try on your own. If you can't, I'll help you definitely. The question goes like this. I'll draw a diagram to make it make easier sense to you. There is a road, straight line road, and there is a bicycle. Bicycle person going in this direction at an uniform speed of 10 meters per second. It's a one-lane road. There is a car. This is the car. This car, when he sees the bicycle, the distance between them is 500 meters. This car is at this point, the initial velocity of the car is, let's say, 25 meters per second. So evidently what will happen, if the car does not slow down, he will eventually hit the bicycle. It's a single lane line, so there is no way they can move around. So if the car does not slow down, sometime after, the car will evidently, obviously, hit the bicycle. The question in this case is, what deceleration what is the minimum deceleration what is the minimum deceleration the car must do to just avoid collision? কোশ্চেন কি বুঝছো বলাবান?
Yes, sir.
Now there is a way to think about this problem. Try to solve this question. Let me elaborate this word a little bit. Just avoiding collision means that there would come a such point where the front of the car will touch the rear end of the cycle but not push. So there will be a slight contact between them, but the car will not at all push the bicycle. So this would mean that all the space and the car would be using the entire space that is available in between them. And in that case, the question of minimum deceleration comes in. It means the deceleration that the car will do, that will be the lowest. I mean, if the deceleration is lower than that, then the accident is going to happen. But if the deceleration is stronger than that, bigger than that, then the car can altogether avoid touching the bicycle and stop further earlier compared to the bicycle. Well, in this case, entirely stopping is not required. That's another thing. To avoid the accident, the car doesn't have to stop. I mean, just avoid the collision. Just to avoid the
Does
collision.
the car has to reach the same velocity as 10 meters per second?
Exactly. Just to avoid the collision, the car has to reach the exact same velocity of the bicycle at the instant they are about to touch or they just touch. So the final velocity of the car doesn't have to be zero. It has to be equal to the speed of the bicycle so that he wouldn't push onto the bicycle. কোশ্চেনটা বুঝা গেছে কি সবার?
No, sir.
আচ্ছা কোন পার্টটা বুঝো নাই বলো, I'll help you more.
Sir, like how decreasing the velocity to the same
Sir,
as the bicycle helps to just avoid the collision.
sir, is it minus 0.525?
I don't know, I have to do the math. I just made up this question, but I'll do it eventually. I don't have the value. The idea is that if the car doesn't slow down, the gap in between the bicycle and the car, which is 500 meter, is gonna decrease, and the car is gonna keep on moving at 25 meters per second. So after this gap is over, the car would have hit the bicycle. Isn't that supposed to happen?
Yes, sir.
We want to avoid that. We want the car not to hit the bicycle. To just avoid the collision, the physical meaning of the word just avoid the collision means that we could avoid the collision by a hair, which means the instant where the collision is about to happen, it just did not happen, which means that the car was decelerating, trying to slow down so that it would not push onto the bicycle. The instance where the speed of the car perfectly matches with the bicycle is also the instance when the car is about to push onto the bicycle. So if you try to visualize, this is something like this: the cycle going forward, the car is catching up on the bicycle, but it's slowing down, and they're both moving forward. There comes a point when the car nearly touches the bicycle, and then it does not touch anymore, because beyond that point of just avoiding collision, the bicycle keeps on moving at 10 meters per second, but the speed of the car goes below 10 meters per second because it is undergoing in deceleration. So that from that point, the gap will also once again start to decrease. বুঝা গেছে?
Yes, sir. I actually misunderstood the question completely. That's why.
সমস্যা নাই, এখন বুঝা গেছে?
Yes, sir. Thank you, sir.
Sure, no problem. Try করে দেখো কি হয়। আমি let me try this in some paper that I have over here. See if I can come to an answer.
Yes.
Yes, sir.
s কত ইউজ করছো 500
Yes.
would the s be exactly 500 think about it as time will go by shouldn't the bicycle also move forward so
Won't it be 700?
no I'm just saying that the distance should be more than 500 that's my point I don't know exactly how much that is I'm starting to calculate that but I'm trying to convince
Sir, what did you get?
I didn't get anything. I just wrote the equation v square plus 2s. Then it popped in my head that I should discuss this with you kids. That this equation might be used, but the s value cannot be replaced as 500 meter. That's my point.
Sir, why?
Because think about it. As the time will go by, because this is a continuous happening. This bicycle would this bicycle stay here or he's gonna move forward?
He's gonna move forward.
So would the car actually cover only 500 meter or is it gonna cover more than 500 meter before that deceleration?
But sir, the car will also move, right?
Yes, and
So
isn't
won't
the
the distance?
cyclist moving at a constant speed?
Yeah.
The cyclist is
So
moving at a constant speed and the car is also moving from this exact position. So total distance covered by the car before it actually gains this speed should it be 500 meter or more than 500 meter? Total distance covered by the car. What does S represent? Displacement, right?
the car will also be moving and the cycle will also be moving. So the distance between them, shouldn't it be 500 meters?
This initial distance between them is 500 meter and the distance between them should become decreased. But think about it. Let's say, let me just copy up, draw this figure again. Let's say
Okay, it has a faster, like more velocity. So
exactly,
distance will gradually decrease as it moves.
exactly. The in between distance will gradually decrease. But would the car exactly make perfectly 500 meter and then reach 10 meter per second, or within that time that bicycle would have also moved a little bit in the front direction? This is the bicycle. So the car would have the option to move a bit more than 500 meter. That's my point. What will be the exact displacement of the car before it actually reaches 10 meter per second? Would it reach 10 meter per second exactly at 10 exactly at 500 meter displacement? Because you have to understand, this is not a stationary object. এটা যদি একটা পোল হইতো বা একটা ওয়াল হইতো তাহলে আমরা পারফেক্টলি 500 মিটার ইউজ করতে পারতাম যে the car is getting close and it will come to stop at covering exactly 500 meter. But that's not the case. As time will go by, bicycle will move forward. So the car will have altogether more distance than 500 meter to go through.
But sir, the car is also moving.
Yeah, the car is also moving. So what my question is, মানে টাইম যত যাবে তত কি হবে? আমি এখানে একটা ধরো সিকোয়েন্সিয়াল একটা ফিগার রেখে দেখাই। Let me get rid of this one. So let's say this is the bicycle, this is the car. Initial distance is 500 meter. After a while, the bicycle is going to move a little bit forward, and from this starting position, the car would move even more. So the distance would be somewhat less than 500 meter. Let's say that distance is now 400 meter. In between distance, that is. Let's say eventually when the car and the bicycle does avoid the accident, so let's say that happens somewhere over here, where the car and bicycle are just touching each other, where their in between distance is 0, and the in between distance is 0, and the speed of both of these things is exactly 10 meter per second. My question is, at this instant, the total distance covered from the initial point by the car, is this still 500 meter or no, or less than 500 meter or more than 500 meter? That's my question.
More than 500 meter.
More than 500 meters.
Do you understand this part? That's the point that I'm trying to get across. That if you use the equation v square equals 2 square plus twice as, in that equation the s gives you the exact displacement made by the object, because we are now doing the math for the car. That final velocity is supposed to be 10 meter per second, initial velocity 50 meter.
So we can't use equations of motions here
We
because
but we just can replace the s by a direct 500. Somehow we have to figure out a new value for the displacement of the car, which should be bigger than 500. Do you get the problem?
yes, sir.
মানে we
Sir, I
can,
didn't get why will the distance be more than 500?
because the bicycle also moved in the towards the right. The car is about to catch up on the bicycle. So from its very own starting point, the total distance covered by the car when the accident was avoided up to this point, is this exactly 500 meter equal, or is it more than 500 meter? That's my question.
More than 500.
The gap in between was decreasing, but the total distance the car would have covered when the accident is avoided down the line, that should be definitely more than 500 meters. So try to figure out that distance first.
Is it 700?
I did not calculate that. আমি একটু calculate করে নেই. I'll try. কেউ কি টাইম ক্যালকুলেট করছো? Anyone?
স্যার একটু দাঁড়ান, একটু ওয়েট করেন।
But কিসের টাইম?
The time when the collision is avoided from the beginning.
Sir, I got an answer. I don't think it's correct. The time.
কত আসছে?
Sir, I got 28.6 seconds.
I got 66.7 seconds.
I got exactly 28.
Did you use simultaneous solving or did you use dual solving? I might be wrong. I'm definitely susceptible to mistakes. I'm a mere human being. So I'll show you what I just did with you. And if there is a fatal flaw, you can definitely correct me. So we'll go through discussion and solve this problem together. Don't worry about that. I found an answer, but I'm not very sure about this, but I would like to show you what I mean. Can I start showing my solution, or you guys would like to have
স্যার একটা কোয়েশ্চেন ছিল।
বলো।
Sir, instead of using like v square equals to u square plus 2s, আমরা কি টাইমিংটা ফাইন্ড আউট করতে পারবো না within the like 500 meters? Because we have the velocity of the car and the distance.
We have the in-between distance.
Car velocity to আপনার constant, right? So v and u will be the same.
Hold up, বলো। Car velocity constant no.
Car velocity constant now?
No. Car is supposed to decelerate to avoid the collision. Bicycle velocity constant.
আচ্ছা স্যার।
বুঝছো কি বলছে? Car velocity যদি constant থাকে তাহলে ultimately accident হয়ে যাবে।
Yes sir.
আচ্ছা আসিফ তুমি আমাকে লিখছিলে হচ্ছে should be less than 500 meter, but it is actually supposed to be more than 500 meter. আসিফ কি এটা বুঝছো কেন 5 more than হবে?
Yes, I got it.
আচ্ছা
স্যার কারের ভেলোসিটিটা যদি কনস্ট্যান্ট হইতো তাহলে তো less than 500 হইতো, রাইট?
কারের ভেলোসিটিটা যদি কনস্ট্যান্ট হইতো তাহলেও তার কভার ডিসটেন্স মোর দেন 500 এ হইতো। বুঝাই, মনে করো এই কারটা আলটিমেটলি গিয়ে বাইসাইকেলটাকে হিট করতে কিছু হলেও তো সময় লাগবে না? It will take some time to reduce this in between gap of 500 meter to 0. So within this time, the bicycle would definitely move a bit forward. The total covered distance of the car would always be somewhat more than 500 meter. The instance the setup is starting, মানে যে মোমেন্ট থেকে আমরা অবজারভেশনটা স্টার্ট করতেছি, at that instant their in between gap is 500 meter. The bicycle moving forward at 10 meter per second, car moving at 25 meter per second. So এই পয়েন্ট থেকে আমাদের ঘটনা ঘটা শুরু হচ্ছে। So if the car eventually hits the bicycle, how far should the car move? Should it be more than 500 or less than 500? Think about it. The actual distance that the car has to move to eventually go forward and hit the bicycle.
More than 500.
বুঝছো কি বলছি?
Yes sir.
মানে obviously bicycle কিছু হলে সামনে চলে যাবে না?
Yes sir.
এটাই।
So the deceleration of the car will be uniform, right?
Yes. Other than that, the maths will not work. I found a value that is minus 0.225 meter per second square. Did any of you come close to this? I might be wrong. I'm not sure.
Sir, I get 0.334.
I got minus 0.375.
Okay. Any of us could be correct. I'm not essentially very confident about my method, but I would like to show you what I did. Should I take a picture and post it on the messenger so that I can go forward it through easier?
Yes, sir.
I think that works
Yes,
better.
sir.
Works faster, I believe.
Yes, sir.
That'll. I'm saying it again that I might be wrong. So I'm willing to discuss my mistake with you. And if you kids have done some other solving which you feel correct, we can look at those as well. So this is a collaboration. পাঠাইছি দেখো তো আসছে কিনা I'll explain piece by piece what I'm trying to show you. Okay. Let me elaborate what I meant. What I'm assuming যে আচ্ছা আমি দুই তিনটা ফিগার একসাথে করে ইউজ করি তাহলে ইজিয়ার হবে. What I'm assuming is that when the collision will actually happen, use a bit thicker pen. When the collision will actually happen, this bicycle would be d distance further down the road from a starting point. I assume this d. So at the instance of avoiding the collision, I mean when the car's velocity will drop down to 10 meters per second so that it wouldn't hit onto the bicycle anymore, the bicycle would have covered d distance, so that, and the car would have covered 500 plus d distance. So I assume this d in my working. So this is the first thing that I wanted to appreciate, that I wrote over here that 500 plus, this is the distance that will be covered by the car and this is the distance that will be covered by the bicycle. Because the bicycle is undergoing uniform velocity, so d equals to 10t. এটা বুঝতেছো কিনা দেখো, speed equals to, sorry, distance equals to speed into time. পোলবান কোথাও কনফিউশন থাকলে আমাকে বলো. Then what I did, I tried to find out the distance covered of the car in terms of the acceleration. এখানে একটা ঝামেলা আছে, ঝামেলা হচ্ছে এখানে আমাদের টোটাল ভ্যারিয়েবল হয়ে গেছে তিনটা, but we're going to work through that. So total distance covered of the car should be 500 plus d equals to 25t plus half at square. মানে হচ্ছে initial velocity 25t, I'm trying to find out the deceleration, which is a, and the total amount of time it is going to travel is same. What is really important for you kids to understand, যে bicycle যতটুকু টাইম ধরে এই ট্রাভেলটা করবে, কারও কিন্তু এক্স্যাক্টলি ততটুকু টাইমে এই ট্রাভেলটা করবে. The time is exactly same for both of them. Can we appreciate that information first?
Yes, sir.
Yes, sir.
ঠিক আছে, তাহলে টাইমটা সবার জন্য ইকুয়াল হবে, সো ওই জন্য আমি টাইমটাকে একটা কমন ভ্যারিয়েবল হিসেবে ইউজ করতে পারছি. সো দ্য টোটাল ডিস্টেন্স কভার্ড বাই দ্য কার ওয়াজ গিভেন বাই s ইকুয়ালস টু ut প্লাস হাফ এট স্কয়ার. এটা হচ্ছে কারের ডিসেলারেশন যেটা আমি বাই করতে চাচ্ছি. দিস ইজ মাই এইম. সো আমি এখানে যেটা করলাম, ডিটাকে রিপ্লেস করে দিলাম, যে ডি ইকুয়ালস টু 10t ছিল, এখানে ডিটাকে রিপ্লেস করে দিলাম. তারপর আমি সাইড চেঞ্জ করছি, সাইড চেঞ্জ করলে পাইলাম হচ্ছে 15t প্লাস হাফ এট স্কয়ার ইকুয়ালস টু 500. এই 10tটাকে এই পাশে নিয়ে গেছি, সাবট্রাক্ট করছি, 15t প্লাস হাফ এট স্কয়ার ইকুয়ালস টু 500. এটা ছিল হচ্ছে আমার একটা ইকুয়েশন. এই পর্যন্ত এসে আমি পজ করছি একটু. Now I needed to find out a relationship which would relate me a and t, acceleration এবং time, এই দুটোকে রিলেট করতে হবে, সেরকম একটা সিনারিও দরকার ছিল. So that's where I came to the direct equation for the calculating deceleration. And acceleration formula কি v minus u by t, তাই না? বলবান.
Yes, sir.
Yes, sir.
Yes, sir.
So what I tried to achieve here in this line is that I wrote the equation for deceleration for the car. Final velocity 10, initial velocity 25. প্রথমে আমি 25 minus 10 লিখলাম. Then I thought, no, this is not supposed to be correct because I'm trying to find out deceleration. So this is supposed to be 10 minus 25. So that's why I actually made that mistake. আমি একদম ম্যাথসের শুরুতে এটা করছিলাম, দেন আই থট হোয়াট শুড আই রিপ্লেস অ্যাজ দ্য ভ্যালু অফ এস, দেন আই ফিগার্ড আউট দ্যাট এটা দিয়ে কাজ করা যাবে না, কাজ করতে হলে আগে এসটা বাই করতে হবে ক্যালকুলেট করে। সো দেন আই ডিসাইডেড টু গো থ্রু ডি। সো ওই এসটা বের করার জন্য প্র্যাকটিক্যালি আমি ডিটা বের করছি, বাট লাকিলি ম্যাথ থেকে আমার ডিটা অটোমেটিক্যালি আউট হয়ে গেছে, টিটা থেকে গেছে। সো দিস ওয়াজ জাস্ট এ প্রোগ্রেস অফ দ্য ম্যাথ। আই ডিডন্ট প্ল্যান যে ডিটা আলটিমেটলি ইকুয়েশনে থাকবে না। হাউএভার 10 minus 25 divided by t equals to acceleration. So এখান থেকে acceleration at the product of at equals to minus 15. এইটাকে এখন আমি আবার এই ইকুয়েশনে রিপ্লেস করে দিছি। কিভাবে রিপ্লেস করছি দেখো, 15t এর মতো আছে, হাফ at স্কয়ার না এখানে, তো এই at স্কয়ারের মধ্যে আমি একটা at কে রিপ্লেস করছি, আরেকটা t আমি রেখে দিছি। বুঝতেছো কি বলছি? খেয়াল করো। সো I divided this half at square, এই যে কই গেল, I divided this half at square like this, let's say 80 into t, এই 80 টুকুকে আমি minus 15 দিয়ে রিপ্লেস করছি, আর এক্সট্রা t টাকে আমি রেখে দিছি। Does it make sense?
Yes, sir.
So
স্যার এটাকে কি দিয়ে রিপ্লেস করেছেন?
একে কিছু দিয়ে রিপ্লেস করে নাই, the total product of a into
আচ্ছা এটাকে you replaced with minus 15.
হ্যাঁ হ্যাঁ, টোটাল 80 টাকে আমি minus 15 দিয়ে রিপ্লেস করছি, and I kept the t intact, so I get this equation at the final. So I calculate the t to be this much, and then I replace the t over here, founded a value of acceleration. Everyone have a good look and see if you can see any fatal flaw in the assumption or the replacement of the values. I'd like you like your inputs. I might be wrong, but because I'm not very used to with these kind of problems, I just made it up.
No sir, this seems perfect.
Acha, what I would like you to do, some of you actually shared your answers, which I really appreciate, that you actually went through the trouble for the thought process. Compare your method with this one and try to figure out the exact point of mistake that you might have done in calculation or you might have done in assumption. But this was not supposed to be like that. This is the part where my thinking or approaching the problem was slightly different than what I did. ওই পয়েন্টটা একটু খুঁজে বের করার চেষ্টা করো. This is important. Pinpoint your exact point of development. Arik,
Yes, sir.
you're unusually quiet.
No, sir. I was just thinking, what? Like I did everything wrong. This.
No, it's perfectly all right. Don't say it's to be wrong. There is always room for improvement. That's why we are doing classes. But see if you can figure it out, that what you are trying to get at and what you are supposed to get at. Rubayat Tasnia, this is your first class?
No, sir.
Did you ever talk?
What?
Did you ever communicate? Your name seemed named to me.
Yeah, yes.
Acha, then my brain is tricking me into thinking that this is your first class. I'm sorry. Please go ahead. I'm sorry. Sorry to bother you. So তোমরা একটু ফেয়ার করে ম্যাথসটা তোমাদের কপিতে করো স্টেপ বাই স্টেপ. So this will be the write up this assumption that let d is the distance that the bicycle moves forward from the point of start and till the accident is avoided. So first define the d in your statement and then slowly go for these steps. First do this part, then do this part, then replace this equation over here, give this an equation number, and then come up with the answer. Fair করে করো যাতে করে পরে বোঝা যায়. Everyone, I'll give you some time.
Sir, can you repeat কি করব?
মানে কোশ্চেনের নিচে সামটা ফেয়ার করে করবা. I would like you to draw this figure first. Drop this 3 set of figures so that eventually you will understand when it comes to the problem that where did this d come from, and then define the d as in statement that let d is the distance the bicycle moves forward till the accident is avoided or till the collision is avoided. The question is the term collision. So let d is the distance the bicycle moves forward till the collision is avoided. So once you define the d, then you write up this set of equations. But এই ফিগারটা অবশ্যই আগে আঁকো, because এই ফিগারটা না আঁকলে মানে you don't have to draw the in between one. I mean, you can draw this one and only this one. You can skip the middle one because 400 meter might be a bit confusing for you later on. But the first stage and the very last stage, these are the two stuffs that I would like you to have in your figure. তোমাদের স্কুলে এখন কি কি পড়াচ্ছে? কার কার স্কুলে কি কি পড়াচ্ছে?
স্যার আমাদের স্কুলে ওয়েভস পড়াচ্ছে।
তুমি হচ্ছে ইয়াতে
মাস্টারমাইন্ডে।
আচ্ছা, সাইন্ডেলে
Work energy power.
আচ্ছা, গ্রিন হেরাল্ড
আমাদের ওয়েভস পড়াচ্ছে মাস্টারমাইন্ডে।
হ্যাঁ, ওয়েভস। ইয়া
স্যার মাস্টারমাইন্ড থার্মাল পড়াচ্ছিল, তারপর থার্মালের পর ওয়েভস শুরু করব।
জি স্যার, শুরু করব।
তোমাদের ফিজিক্স মোট কজন টিচার নিয়েছেন?
প্র্যাকটিক্যাল একজন স্যার আর থিওরি একজন।
How many classes do you have per week?
Sir, theory I think 3.
Theory 3 classes and practical একটা।
আচ্ছা, so that's possible.
স্যার আমরা স্কলাস্টিকার রেডিও অ্যাক্টিভিটি করতেছি।
Why?
I don't know.
That's the last chapter of the syllabus. So it's a pretty interesting chapter if you ask me. Okay, আর ইয়াতে লাবিব গ্রিন হেরাল্ডে কি পড়াচ্ছে এখন?
Sir, moment.
আচ্ছা, ওকে। ESS
current or practical electricity.
Current or practical electricity. Okay. So it's all over the places, to be honest. আচ্ছা, তোমরা একটা ফেয়ার করে করো। I'll bring in this. I think the figure drawing is complete, so I'll bring in the solution. এটা গুছায় করো।
স্যার মোমেন্টের আগে আপনি ইলাস্টিক করাচ্ছেন যে? স্যার
Yes, Asif, I can repeat how I got d equals to 10t. That d is basically the distance covered by the cyclist over the duration of t. So speed equals to distance into time. Sorry, speed equals to distance over time. So distance equals to speed into time. 10 meter per second is the speed, t is the time. So, বুঝছো? Okay, I'll give you 1 more minute to finish up. That should be enough.
স্যার ইলাস্টিক যে আগে করাচ্ছেন মোমেন্টের আগে,
সরি
না ইলাস্টিক চ্যাপ্টারটা করাচ্ছেন যে মোমেন্ট আগে আছে তো।
এখানে আচ্ছা অ্যাকচুয়ালি সিলেবাসে আমি যখন কম্পাইলেশন গুলো করছি মানে ব্যাক ইন টাইম তখন আমি পেপার ওয়ান এর কম্পাইলেশন গুলো আর পেপার টু কম্পাইলেশন গুলোর সিকোয়েন্স হলো ফলো করছি। ইফ ইউ কম্পেয়ার দোজ থিংস ইউ উইল ফাইন্ড আউট দ্যাট দোজ সিরিয়াল নাম্বারস ডু নট ম্যাচ অ্যাট অল। সো I picked up elasticity because it's a pretty small chapter to deal with, can be finished because practically elasticity discussion actually shesh, including P1, P2 and this lecture as well. So I'll be finishing up this remaining problems of this worksheet and then I'll be jumping to moment. বুঝছো?
জি স্যার।
Okay.
স্যার আমার একটু থিঙ্কিং ডিসটেন্স আর ব্রেকিং ডিসটেন্সতে সমস্যা আছে।
বলো, I'll help.
মানে একটা কোশ্চেন আছে ওইখানে থিঙ্কিং ডিসটেন্স আর ব্রেকিং ডিসটেন্স চেয়েছে।
Okay. Thinking distance is the distance covered over the reaction time, and braking distance is the distance covered over the deceleration. দুটাকে সাম করলে হয় হচ্ছে স্টপিং ডিসটেন্স, which is the total. This one is done, everyone.
Yes, sir.
জি স্যার।
Acha, let's move on. So 25 এ আমাদের একটা গ্রাফ আঁকতে বলছে. Drawing the graph should not prove very difficult. The car is traveling at a uniform speed of 80 meters per second. T equals to the rabbit is a child running out of in front of the car. At time t equals to 0.6, the driver starts to apply the brakes. The car then descends uniformly, taking a further 3.60 seconds to stop. This word further is very important. Many students read this word but cannot capture it, so they mess up the graph. So এই গ্রাফটা আঁকতে হবে. This should be pretty simple. Getting rid of all of this. So এখানে আমাদেরকে বলছে হচ্ছে the car was initially traveling at a uniform speed of 18 meters per second. Then in 0.6 seconds the brakes were applied. So if I have this graph, we would have a straight line up to 0.6 from 18. So this is 15. Every two division is 1. So 15, 16, 17. This should be 18. Goes up to 0.6 second. And then it should reduce to 0 up to within 3.6 seconds, which means this would be my finish point, because it says a further 3 seconds is required for the stop. So from here through here, this is how my graph should look like. ঠিক আছে না? 3.6, 0.6, starting from 18. I think it's good. আচ্ছা, এরপর বলছে হচ্ছে calculate the distance traveled in the first 0.6 second of the motion. The braking distance is the distance traveled by the car after the driver starts to apply the brakes. The braking distance is not the same each time the car stops. State two factors that could increase braking distance. আচ্ছা, braking distance increase করা অনেকগুলো বুদ্ধি আছে. Braking distance increase করার বেসিক মিনিং হচ্ছে যে আমাদের কার ডিসেলারেশন কম হয়েছে, অথবা যে ফোর্স দিয়ে আমরা ডিসেলারেশন করতেছিলাম, ফর এক্সাম্পল দ্য ফ্রিকশন ফোর্স বিটুইন দ্য টায়ার এন্ড দ্য রোড, by some physical factor that force became weaker than it should be. For example, it can be slippery road, it maybe it was raining, there were loose sand or asphalt on the road. It is also possible that the braking mechanism had some air in the system, so it was not applying full brakes. Or you can say that the brakes were not pushed all the way down. The brake lever was not floored, so it was halfway pushed, so there was less braking force available. So there can be a lot of different factors for braking force, but for an increased braking distance. But it is altogether dependent upon how much frictional force could you possibly get out of the contact between the tires and the road, and how well did the braking system of the car itself could work, and how much the brake were pressed. These are the three variables which can affect the braking distance. So you could write any two of these over here, which could increase the braking distance. If we look for the Mars scheme, this is 25. আচ্ছা এটা তো on MCQ, we should go for up above 25 25 25. There were okay, we only have the examiner's report, so we have a look at it. Candidates were usually able to produce sensible graphs which showed that the car started at 80 meters per second, continued to speed at the speed for 0.6 and then slowed uniformly to rest at 3.6 seconds. In part B, there are many factors that increase braking distance. Example: poor tires, slippery or wet road, applying the brake with a weak force. Many candidates fail to state factors that would increase the braking distance, and mainly factors that affected or even decreased the distance. These candidates were given a credit if they gave two factors. আচ্ছা, মানে হচ্ছে mentioning the factor only is not gonna be good enough as per the examiner. What change of that factor is required should be also mentioned. For example, if you write that slippery road because reduced friction, this is a good response. If you just write road condition, then that's not good enough, because the road condition, a dry road condition might actually decrease the braking distance, because that might actually help for an increased braking force. So mentioning road condition is not good enough. What road condition is gonna give you increased braking distance, you have to mention that specifically. That's why slippery road or wet road is a perfect good answer, or not applying the brakes fully is a perfect good answer. Or you can say that worn out tire is a perfectly good answer. But if you write tire condition or the age of tire, then that's not very specific enough, because old tires are going to behave one way, new tires are going to behave another way. You should say that old tires or worn out tires. That's the specific. So that's what the people are saying. বুঝা গেছে এই কোশ্চেনটা সবার?
Yes, sir.
আচ্ছা, এরপর আছে 26। এটা গ্রাফটা আঁকতে পারছো বলবান?
জি স্যার।
আচ্ছা, there seems to be no problem from anyone.
Sir,
Yes,
I have problem in number 31.
31. Okay, we'll go for it. Yes, bolo.
Sir, the statement here that his acceleration is non-uniform until he reaches a steady speed of 50 meters per second. So how would we understand if the acceleration is in decreasing or increasing rate?
From experience, after the parachute is opened, আচ্ছা না, when the parachute এই পয়েন্টটা বলতেছো না এটা, you said about this line, right?
Yes, sir.
You have to understand this, that when the parachute is not opened, then the acceleration is actually decreases, which means the graph slowly becomes slanted and eventually becomes horizontal to represent a terminal velocity. So you have to recall the actual shape that you know for the graph for the parachute is something like this. So that part of the graph was before opening the parachute, so you have non-uniform acceleration in this shape. This you have to infer from your own understanding. বুঝছো কি বলছি?
জি স্যার, বুঝেছি।
সো এই গ্রাফটা হবে হচ্ছে ওই জয়ী শেপের মতনই। আচ্ছা, এই গ্রাফটা কিভাবে আঁকতে হবে সেটা আমি একটু তোমাদের দেখাই দিচ্ছি। এই গ্রাফটা আঁকার মধ্যে একটু কিছু হেল্প করার ব্যাপার আছে। It's a good question that you picked. How can I select this with the select button? Acha. Let me show you. Question number was that the driver starts from rest time t equals to 0. So এখানে আমাদের একটা পয়েন্ট আসবে। His acceleration is non-uniform until he reaches a steady speed of 50 meters per second at t equals to 10 seconds. So the idea is okay. We are expecting to have an uniform velocity of the parachutist at from the instance of 10 meters per second with a value of 50 meters per second, which means from this point we should expect a horizontal line. For how long I'm not sure. I'm gonna figure that out a bit later. But এই পয়েন্টের আগ পর্যন্ত আমাদের নন ইউনিফর্ম অ্যাক্সিলারেশন হওয়ার কথা। সো এখানে বলছে হচ্ছে হিউম্যান প্যারাশুট t equals to 20 সেকেন্ড। তার মানে হচ্ছে এই লাইনটা লম্বা হওয়ার কথা হচ্ছে আপ টু 20 সেকেন্ড। সো এইটুকু হচ্ছে আমাদের this part represents the uniform velocity, the terminal velocity of the person parachutist before opening the parachute. And important পার্টটা হচ্ছে যখন আমরা এইখান থেকে এই পার্টটুকুকে মার্জ করে আঁকাবো, what is really important, এই পয়েন্টে আমাদের কোনো কিঙ্ক হতে পারবে না। কিঙ্ক মানে হচ্ছে you would have to draw a line that is smoothly joined with the horizontal bar. So the line should look something like this. আমি তো অনেক কিছু আগে ফেললাম। The line should look smooth like this. It cannot look like this. For example, let's say এরকম, and then there is a visible sharp corner, and then there is a horizontal line. এরকম কর্নার হইতে পারবে না। So এটা করার সবচেয়ে ভালো বুদ্ধি হচ্ছে, as if you ask me, is that you try to place your wrist over here, somewhere over here, and invertedly draw this part up, so that this is what I'm going to try in my drawing pad without try to get a gradient over here. So try to draw a smooth line, not curved like this. It's very difficult to draw on plastic surface. And once you get a good line, then you can have it joined with a beautiful straight line from here all the way up to here. Because এই কোশ্চেন আমাদের কোথাও ইনিশিয়াল কি বলে অ্যাক্সিলারেশনের কথা বলেই নেই। So it would be a good idea to start the graph from here, draw in anti-clockwise direction, and then complete this part. And equally goes for here as well. Yeah. After this, it says he opens the parachute at t equals 20 seconds and decelerates until t equals 25. From t equals 25, he falls at a steady speed of 5 meters per second. So 25 থেকে একদম শেষ পর্যন্ত আমাদের 5 meters per second একটা ইউনিফর্ম লাইন থাকবে। So which means this is supposed to be our terminal velocity after this thing. So আমাদেরকে এইখান থেকে এই পর্যন্ত একটা স্মুথ জর্নি আঁকতে হবে। Once again, এই জর্নিং এর মধ্যে এখানে কোনো কিঙ্ক হতে পারবে না, বাট এখানে একটা শার্প কর্নার হবে। So what would be a good idea? You can and you should place your wrist somewhere over here and use your hand movement to draw a smooth curve out to eventually join up over here. So I can try to show you maybe like this. নদীর মতো আঁকা বাঁকা হয়ে গেল। But you start from here. Don't try to start from here and you should join up over here, because this makes it pretty difficult to make the smooth joining. Did you get my point? Boloban?
জি স্যার।
Yes sir.
কিঙ্ক গুলো যাতে না হয়, এরকম ভিজিবল কর্নার যাতে আমাদের গ্রাফের অ্যাপ্রোপ্রিয়েট জায়গাগুলোতে না হয়। আচ্ছা, this is 7:34, so we'll stop today's class right here and we'll pick up from this point and go onwards in the next class. Thank you very much.
Sir,
Yes.
you didn't tell us the admission for new students.
আচ্ছা, এটা তোমার পরে বলবো, সমস্যা নেই, ডোন্ট ওয়ারি, ক্লাস করতে থাকো, আল্লাহ হাফেজ। আর তোমার ওই ফ্রেন্ডকে আমাদের ক্লাস 9 এর গ্রুপে একটা ইনভাইট দাও, আমি পরে তাকে অ্যাড করে নেব।
Okay sir.